Recording.
Recording is on.
Okay, hi everyone. So, in today's class, we are going to discuss the graphs problem. It's a kind of graphs, but it may not be, but it's kind of a graph related problem, which is celebrity problem. So, last week we discussed about the given weighted graph and Dijkstra's algorithm, which is like given weighted graph, find the shortest path between two nodes, and it's kind of complex algorithm we discussed. So, we have video and we have a coding link available in YouTube. So, please go through that if you need any question, if you have any questions, and you can also ask me in the meeting as well. So today we are discussing the celebrity problem. So anybody heard about the celebrity problem? Karanya or Aravind, did you get a chance to
No,
explore?
no, sir. I haven't heard of.
Okay, so this is very interesting problem.
To find a person who knows everyone with minimum number of questions, right? Am I
Yep,
correct?
similar to that exactly. So, yeah. So we need to define the problem as well. I did not define the actual the problem in wordings. We will also do that. So I will show you what is celebrity. The definition of celebrity. Somewhere definitely there will be in online. I did not search. Maybe we can do a quick search in online. I'm just doing just to find the actual definition. Celebrity problem. Yeah, here is the one I already found here. So let me bring to this screen here. So I don't know what process, what approach these guys solved, but I solved in a different way. So here is the celebrity problem. In a party of n people, okay, only one person is known to everyone. Such a person may be present in the party. If yes, she or he doesn't know anyone in the party. We can only ask questions like, does A know B? Okay. So find the stranger or celebrity in the minimum number of questions. We can describe the problem input as array of. So here is the main algorithm. Celebrity. What is the celebrity? Like celebrity, the definition of celebrity is like this. Okay. So they're saying only one person is known to everyone in the party. Okay, only one person. Such a person may be present in the party. Okay, if yes, if that person present in the party, okay, if that person is there in the party, he or she doesn't know anyone in the party. This is another condition. So everybody knows that celebrity, and he doesn't know anyone in the party. That is called celebrity. Okay, so did you understand, or does it need any little bit example? I can give you an example. Okay. So cricketer Sachin Tendulkar just completed century and the complete the let's say the session is completed, and he ran around 120 or 130 scoreboard. Now he is coming back to the pavilion. Once he is coming back to the pavilion, there will be so many people asking for the signature or photo or something, right? Let's say around 20 people gathered around Sachin Tendulkar. Now this Sachin don't know anybody in those 20 people. Those 20 people are completely unknown people to him, right? But all those 20 people know Sachin. Who is Sachin? What he does, everything. That is called celebrity. You guys understood?
Yes, sir.
Let's say in those 20 people, there is one person who already spoke with Sachin before, and Sachin already know him. Let's say he is a driver of. Let's say he is the driver of Sachin's car. He know him. He is also approaching. Then in those 20 people, one guy Sachin know one guy, right? Of course, in the real time, Sachin is still a celebrity, but in this example, Sachin is not celebrity anymore because because he knows one guy, right? So he's not a stranger to everybody, and that guy knows him, and he's so not everyone is unknown to Sachin. One of the person out of 20 people, one guy is there which is known by Sachin. So that's why then in that situation we don't call him a celebrity. That is the main situation here. He doesn't know anyone in the party. So the celebrity should not know anyone in that pool of people. He only rest of the people, everybody in the party knows that guy. That guy doesn't know anyone in the party. Then only we call as the celebrity. Okay. So that's a little bit weird definition of celebrity. Don't think that this is exactly the real time or the real life example of celebrity. Okay. So that is the condition in this algorithm. So I can also copy and paste here. So they look at the input. They have given in a matrix. So that's what I'm saying. Like the graphs problems, there are different ways of representing in matrix is I felt so difficult. So the writing algorithm is also confusing. I always go with the same notation of node, just starting from trees. I want to follow the same pattern, starting from linked list, creating a node object, and having the properties, trees, linked list, trees, graphs, everything. I want to follow the node pattern rather than the matrix pattern. Here, these guys are giving a matrix kind of pattern, so I don't want to go with example here. I will show my example. Okay. So let me know if my voice is breaking or if I'm going really fast. Okay. Can you guys see my inking slate here?
Yes.
So here is the connections. Okay. Can you tell who is celebrity in this graph according to the definition I shared? So here one node A, right? So A goes to B. So here we need to find the celebrity, right? So A goes to means A goes to B means A knows B. So the guy A knows B. Okay. B knows C.
He is a celebrity.
Exactly. Exactly. In this party of the 6 people, C is the celebrity. So how to find the celebrity? Okay. So why C is celebrity?
Everyone in the party knows him except
Everyone in the party knows
It
C.
has only incoming edges but no outgoing edges, right?
Exactly. That is the technical definition. So in the normal definition, everybody in the party knows C, and C doesn't know anybody in the party. That is the thing. So everybody say, let's say C is Sachin. C came into the party and everybody want to go there and want to take a picture or want to take a signature. What is that? The sign, right? The autograph. Then C don't know anybody in the party, but he is celebrity. So let's an example, as I said before, in case by any chance the C knows A, just by any chance, then the algorithm breaks. So there is no celebrity here. Basically, you can also think of this acquaintances. This is also called acquaintance this problem. The other terminology is let me show you that. So it is called acquaintances. I'm still not properly spelling or the pronouncing. So what is the definition of this acquaintance? So let me tell you this. It's not knowing. It is like the definition like this: a person knowledge or experience of something. So um, here in this algorithm, a person one knows slightly but who is not close friend. So that is called
Acquaintance.
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 So basically, so here here if you look at the A, right? A acquaintances with the B, C, E, because A no, basically it's not like friendship, but knows. A knows about B, A knows about C, A knows about D. So A is acquaintances with B, C, D. Okay. This is also called acquaintances problem. So there are two definitions of this problem. Some people call celebrity problem, some people call acquaintances problem. Okay. So A knows B, C, and D, and C also knows A. It's not like a friendship, but somehow C knows about A. In this situation, no one is celebrity, because it's kind of just C is not a stranger, right? So in this, in the definition of the problem, if you have something like this, then we will simply need to return saying there is no celebrity in this algorithm. Okay, but if you don't have this, right, if we don't have this connection, now C is the celebrity. And also, let's say one more example. If we don't have any of the connection, let's say we don't have this connection. Look at this. E knows only D. E doesn't know about C. So then that means E is something he don't know about Sachin. Who is Sachin? So then also there is no celebrity here, right? Because C is not celebrity anymore. Because C known by only other people, A, B, F, and D. Because E doesn't know C, C is not a celebrity. This is another situation where there is no celebrity. Are you guys clear with the problem? Any questions?
Yes.
Yeah.
Suresh, what if a celebrity has an incoming connection from himself?
That's a good idea. So this is kind of this thing, right? I think you can treat that as a celebrity, because he knows himself, right? If person doesn't know about himself, then he's not even a person. So so this is not a problem.
He has acquaintance with himself, so it will
Yeah. I
returned
don't
as
think
true.
I don't think that will disqualify the celebrity definition. Okay, that's a good question though. Yeah. So here is a lot of input, and here is a look at this 11 minute video is there, but most of the videos they will use matrix. That is the problem I found. I doesn't want to go the graphs problem with the matrix, because that will complicate the things, in my opinion. Since as I said before, since the following of the node linked list, I usually follow the node class and easy kind of linked list and list kind of thing. Maintaining a list is so better and easy for me rather than going with matrix. If you guys want to still want to go with the and try to understand these problems, go with it. So you can just search for celebrity problem, you will find a couple of videos and all. But let's look at the way I solved this problem. Of course, it's not something I also found somewhere. So now let's see how to solve this problem. Let's say in a real life example, we are not going to solve computer problem. Now these guys are there. Now we need to ask the exact same question like this guy said, right? So we can ask only this question. We can only ask the question like this: does A know B? So we can ask this question and we can figure out the celebrity. So how are we going to decide the celebrity here? So by looking at since we have only 6 nodes, you just looked at there and you looked at all the arrows and you simply saying, oh, she is celebrity. But in a technically, let's say if you have if I give you the 50 nodes, it will take at least half an hour or so to figure out. If I am giving you 100 nodes, how are we going to do? So in a board itself, in a whiteboard, let's forget about writing algorithm. How are we going to do? If I'm giving you 100 nodes, a graph with 100 nodes, what you do with it? Any ideas? Or think about. Sorry, go ahead. Someone is talking. Yeah, go ahead. Go ahead, Arvind. Do you want to share something?
No, Suresh, no.
Yeah, speak out. And if you have any, it's kind of discussion. It's no problem. Have a casual discussion. Yeah.
The naive approach is checking whether the two nodes
Exactly.
have the weight and resulting it in true. So, and recording the acquaintance of each and every node.
Exactly.
And find the most repeated node.
Very good. Very good.
Not the most repeated node, the node which known by have path from every node.
Exactly. That's the way to find. So let's assume all these six people lined up in a real life example. All the six people are in a hall, in a party hall. Now you are the administrator of this program, and now you came to the party, and all the six people are there. Now you need to figure out who is celebrity. What you do in a real life example? What you do? Because this is in a real life. What you do is, as Karunya said, let's take two people. Okay, come these two out of this pool. Let's take these two people, and we will ask the exact same question. Let's say this is node 1 and this is node 2. Okay, does node 1 knows about node 2? Do you know? Just asking. These are two persons, right? Say Karanya and Aravind. Hey Karanya, do you know Aravind? We will ask that question to this guy. If we say yes, what is meant by that? If we get yes, so it's very complicated. It's very little bit of tricky to understand here. If we get s to this answer, if we say yes, if node 1 knows about node 2, what we can say is definitely we can derive that n1 is not a celebrity, right? Are you guys agree with that? Because n1 knows n2, that means he so celebrity definition means this guy should not know anybody, correct? Are you guys agree or not?
Yes, Suresh.
So
So that
if
should be N2 should be a stranger.
it could be, yeah,
Like
we don't know whether n2 is a celebrity or not. We did not ask any question n2 yet. So we asked only n1. We asked about only, we reached this n1 and saying, hey, do you know n2? We asked only one question, and we will get only yes or no answer, right? So we got yes. If yes is there, then n1 is not a celebrity. N1 is not a celebrity, right? Arvind, are you following? I think Arvind, your network is
I
really
think
poor.
the network is down in this area.
Yeah. So let's say if you get no, answer is no. What does it mean? So n1 doesn't know n2. What does it mean? Any guess?
It means N1 doesn't know N2, but N2 might have known N1. The other way is also possible, right?
No. So n1 doesn't know n2. Yeah, we don't have. We are not asking any question n2 yet. So we asked only one question. Do you know n2? We are asking n1. Do you know n2? Okay, we got
Okay.
no. If we says no, what does it mean? There are two answers. We will get two answers here. One is here also the same thing. In the first also we will get the two information, two inputs we will get. First one is n1 is not a celebrity, and the second information is n2 could be a celebrity, right? We don't know because
Yeah.
n2 could be a celebrity because we this is not sure, but for sure this is for sure. N1 is not a celebrity for sure. If we say yes, right? And n2 could be a celebrity. That these are the two important information we will get. How about no? If we get no, n1 doesn't know n2. What does it mean? For sure we know one information. If n1
So
doesn't know n2,
N1 might be the celebrity.
yeah, n1 could be or might be. Yeah, n1 might be a celebrity. And another thing is there, very important information. What is that? n2 is not a celebrity for sure, because in this situation n2 is not a celebrity because n1 doesn't know about n2. The celebrity definition is everyone need to know about that guy.
Okay.
You understood? So in this first situation, n1 is not celebrity because he knows someone. In the second situation, n2 is not a celebrity because he doesn't know by another person in the group. You following?
Yes, Suresh.
So this is very tricky, but we need to slightly understand the difference. So
So by
we
using this method, we are eliminating the nodes, right?
exactly now, now in always go with real life example. Forget about the algorithm, forget about the logic. Now, how are we going to solve this? Now, based on this answer, now let's say if yes is there, we are sure n1 is not celebrity, then what we can eliminate, we can say, hey, go back. So we need to care about n2, because we already know n1 is not celebrity for the s. If you say yes, right, then what we can do is we can safely eliminate one guy. Which guy? If we get yes,
Yeah,
which
we can say if we get yes, we'll eliminate N1.
exactly we can
If
eliminate
it
l1
is no,
n1.
I will eliminate N2.
Exactly, that is the main logic here. So if we get yes, right, then we need to stick this guy, because we haven't asked any question about n2. We will wait for we'll keep this guy, and we will ask n1 to wait outside or something. Okay, go back. Out of these two, we already processed these two guys. Now in this position, what we do, we'll pick one more guy here. Okay, stand here, wherever the place, this is the place, became empty, right, because n1 went outside. Now we will take one guy here and put it in the same location. We'll take two places, let's say two chairs. There are two chairs on the stage, and we are asking this the third person to sit here, and we will ask the exact same question. So based on the answer, we will eliminate either this chair or this chair, the person in this chair or person in this chair. Based on the answers, we will eliminate that persons, and we will invite another person to sit in the chair, and we will ask the same question. Got it? Finally,
Okay.
after processing all the people, what happens is, we will get no more persons in the hall, and we will get an answer. We'll get, let's say we got nk and I. Let's say this is I and nj. Let's say I and j. This is I, and this is j. You process these many people. Okay. Now okay, now you processed ni and nj, node I and node j, and you asked the same question. Hey, ni, do you know nj? Let's say yes. In this situation, yes means, then there could be a possibility that this nj is a celebrity. Okay, there could be a possibility. If we say no, then n1 could be a celebrity. Now in this situation, the problem here is, since we completed all the nodes, we cannot simply say, hey, this is a celebrity, and we cannot celebrate the success. The problem here is, we are checking only these two nodes. We haven't checked whether another nodes which we already eliminated, which are outside the hall, whether those people know this guy. The problem here is, we are not checking one node with everybody. We are only checking two people at a time, and deciding who needs to go out of the party. But at the end of the day, at the end of the program, at the end of the process, we figured out either n1 or nj could be a celebrity. Now let's say we got the s here, then we will take the nj, and we will run the problem again with all the nodes n1, n2, n3. Hey, n1, do you know nj? N2, do you know nj? N3, do you know nj? If we get yes, 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 yes for everybody, then only nj is a celebrity. And at the same time, for every, we will ask the same question for n1, n2, n3. We will ask the same question. Do you know nj? And do you doesn't know n1? Do you know nj? Do you doesn't know n2? We will ask the same question to make sure that everybody knows this node j, and node j doesn't know anyone in the list. If that is a kind of a check we need to do at the end of this process, because
So if
we have
he knows any one person in the list, or else if he maintains some adjacency list than himself, then he is rejected as a celebrity, right?
celebrity. Exactly, in that situation we can simply say no celebrity exists. because we already processed the two nodes, and we already eliminated n1, n2, n3, n4, and n I minus 1. We already eliminated all the people all the way from n to n I minus 1. Now we are deciding whether nj is a celebrity or not. But if any one of these break, if any one of these condition breaks, then immediately we will call that there is no celebrity in the algorithm. Okay, so if we find a celebrity, if we guess yes for all these conditions, then we can simply say, announce that nj is a celebrity. Oh, we lose Arvind. Actually, he is a very interesting problem. I don't know, maybe his network is really bad, or what he's saying. Maybe he's offline, so shit. Yeah, let's see, maybe he will come later, or maybe he will listen the recording. Okay, so you got the algorithm, right, Karanya?
Yes, Suresh.
So this is the way to do in a real life. That's what you do. You take two chairs, and you ask each two people and sit on the chair, and you ask the exact same question, and you will decide who needs to go out of the party. Party in the sense, who needs to out of the hall, and then at the end you will decide whether you found a correct person or not. So we can run this exact problem with the same input. Okay, let's do the exact problem with these inputs. I'm
So
going to erase.
So logically, we have to maintain adjacent nodes for every node in the graph, so we can find the relation. Okay.
Yeah, that is already given. That is what the given input. Everybody, the graph is given. Like you will know how many people in the party, and you will also know each person has what are the connections to that person has. So you already know the adjacency list. The adjacency list will be given. Okay, so only thing what we need to figure out is the celebrity. Just you can ask this question n number of times. You can ask the question, as I said, do you know this guy, do you know that guy? No, in the sense celebrity, like basically no in the sense the adjacency list is n2 is part of the adjacency list of n1. So n1 no, n2, what is meant by that is, I will show you. It is tough to eliminate each problem here, each diagram, because otherwise we'll lose the entire diagram on the left side. So here is the, let me show you. So if you are asking like this, A knows, KNOWS, A knows, or A has connection, or means that means if you're asking yes or no, that means is A connected to B or not. Basically, every node has adjacency list, right? As I said, every node has a node information and adjacency list. What is the elements of the adjacency list of A? Can you tell me how many elements in the adjacency list of
A
A?
has D, B, C. That's it. A has D, B, C. Those three are the adjacent.
Exactly.
Will be there.
Exactly. That's what we do. The function either knows or has connection. This has connection. A has connection to B. A dot has CONNECTION connection B. This returns true or false. Does it return true or false?
It returns
Because
true.
A has a connection to B. Yeah, true. Right? Now if I ask you like this, B has connection to A, what is the answer?
B has
B has
connection
connection to A.
to. No, it's false.
It's false. Yeah, because B, in the B adjacency list, what are the elements in the B adjacency list? Only
B,
C.
C, and only C.
Only C. B is not connected to any other node. Now tell me the adjacency adjacency list of C, adjacency nodes of C?
C has no adjacency list. None.
C has no adjacency? Zero,
List.
because there is no outward thing, right? Yeah, okay. So let's see. Can we say that? Can we simply say if the adjacency is zero, if the adjacency list is zero, can we say that node is celebrity?
No, Suresh.
No, because C needs to be in the every
Known
adjacency
by
list of
everyone.
exactly. This is the one condition. There are two conditions for the celebrity. The node doesn't have any adjacency list. The adjacency list is zero, empty, and the C must be in the adjacency list of every node.
Everyone else. Okay.
That is the condition. We need to check that.
So that's why in that matrix 2 comma 2 is 0.
2 comma
So
2. Oh, I am not following the matrix approach. Like
yeah,
it will confuse my
I
mind.
just
If
saw,
I'm
I want to ask the
yeah,
question, but we
sure.
moved to this one. Now I
Exactly.
understood.
We can follow matrix approach as well, but it will confuse my mind a lot. If I'm following two approaches, right? That will problem. Yeah. So this is another way of representing. Yeah. You're talking about this matrix, right?
Yes.
Yeah. But anyway, I'm not following the matrix approach. You feel free to follow that. I follow this node and adjacency list approach. Okay. Cool. Yeah, this is algorithm. Now tell me what data structure you use, how many loops you want to write, how many methods you want to write. I told you the secret. So now I formula, like what is that, the vaccine formula I gave you. Now you need to develop the vaccine.
So
How do you develop the vaccine?
for every
For-
node in the graph,
Yep.
usually the graph contains all the nodes. So for every node in the graph, I'll take I'll take 2 nodes in the graph,
Okay.
the first 2 nodes, and check whether they have connections. Like the node A dot has connection or as acquaintance of A and B, I'll pass that. If it is
Yeah.
true, and if it is true, I'll eliminate the A and take the B as the temporary celebrity, and
Yep.
I'm going to check the other nodes. Already I have
Yep.
eliminated one node. I'll
Yep.
go to check C, D, E, and F with B, so on, and the temporary celebrity will change
Yep.
until the real celebrity has connection, only the incoming connection to all other nodes. So that is how
Exactly.
I'm going to check between the two nodes and change the celebrity.
That's good. So you're saying like you're going to take the temporary variables to just like chairs. As I said, you have a stage and you have two chairs. That means two variables. You will use those two variables to represent A, B, E, C, B, D, P, C, whatever the two people, right?
Yeah,
You will have that temporary variables to maintain those because you need to write that logic. Do n1 no n2, that is the logic. N1 n2 is a variables, just n1 n2 is just two pointers or two variables, right?
yeah.
So you can take that. And how about the looping? Because here you
Yeah,
have only 60 nodes. If I give you the 100 nodes, what do you do? How you do you use for loop or
for
while loop or,
each node in the graph,
yeah.
I will pass. I'll take the temporary celebrity as I'll take a for loop, Suresh. In the for loop, I'll assign a temporary celebrity as the first node,
Okay.
and I'll pass the first 2 nodes in the function. So the function will return the celebrity node, which is among 2 nodes, which is this temporary celebrity, and this
Yeah.
temp will change accordingly. The final once we go through, for example, if I pass A and B,
Mhm.
it will give B, not A.
Yeah.
So
Yeah.
in the same way, if I give B and C, it will give C.
Yeah.
So if and already I have eliminated A and B, so now I can go with D and C. It will give C,
Yeah.
and F and C. It will give C.
Yeah.
But there is a condition E and C that really disturbs me. I don't know how will we process that. There is no
What is that?
connection between C
D and C.
and E
What
and
is
C.
the
They have
what?
no connection.
Oh, it's D and C. Wait. So let me put this. Let me put this back to. So you're saying this one. This is there. This connection is also there. Now C is
Okay.
celebrity, right?
Now it
So in
will
this.
again it will pass C. Now there is no more node in the graph to process, so my celebrity is C. That's how come I came up with this answer.
Yeah. So now, so what is the best data structure? Do you think, do we need any data structure, or we doesn't need any data structure other than just a for loop and two variables?
In a data structure to compare.
Yeah.
Actually, in my graph, 1 second, I'll open it.
Yeah.
In JavaScript, I used set data structure to store adjacency list, and
Okay.
to process. I don't think.
So
Okay, but I can't come up with any data structure. Can you please help?
yeah, so basically we I think there is there is a possibility to do without data structure, without any another additional data structure, but it would be nice, it will make our life easy if we use a particular data structure. So let me explain the let me show you the algorithm first. Okay. So
Okay.
I don't know whether I wrote in or maybe I did not even start the here. I need to create one. So but anyway, I can show you directly in the GitHub. Okay, it is there in the GitHub.
Mhm.
So here is my person class. Okay, it's a person, right? So person class has a character. This is the name of the person. Okay, and this is
Okay.
acquaintances. This is acquaintances. That acquaintances means adjacency list. Okay,
Adjacent list. Okay.
adjacent list, a list of persons. This person knows these many list of people, right? So this
Mm-hmm.
is just a public property which will give all the acquaintances of this person. Just returns this list, return the list in a form of array, and here is a constructor, right, which will just initialize the person. And here is add acquaintances. Basically add acquaintances means just it will update the list, so we no need to worry about that. This is the function I'm telling you as a bool, true or false. So this guy knows P. That means like acquaintances contains P, right? So if we are saying
Okay.
like A knows B, that means if the B is part of the list, right? If the acquaintances contains P, that means true. It will return true, right?
Okay.
Did you understand this algorithm? This particular
Yes,
function?
Suresh.
Yeah, you can send anybody, like if this person is a Suresh. Now if you send here Karunya, like Suresh is Karunya is part of one of the acquaintances. Yes, so in the list of acquaintances, if you for the person Suresh, in the list of acquaintances all the people will be there. Modit will be there, and Aravind will be there, and Karunya will be there. Then it will simply return true. Okay, that's how it is.
Okay.
Now here is the actual algorithm. This is exactly the same graph which we had on the other screen. I created all the six nodes here, and here is the A acquaintances with B, C, D, right? So look at the graph here. If you look at the graph here, you can understand, right? A has connections with the B, C, D, and B has connection with C, and D has connection with the B, C, F, right? So B has
Yes.
connection with B. No, D has connection with B, C, and F. It's going upwards. So and also the same thing. Now F has connection with C. So try commenting this line. If you comment this line, what is that means? F connected to C. If you comment this line, that means F does not know C. So if you comment this line, what will happen is basically this one we are eliminating this line rather than E. Let's say if you are eliminating this line, again the C is not celebrity, right? Because F doesn't know anybody. There is
Okay.
no connection from F to C, right? So this is just an example. So you can try your algorithm by removing any of the connections and make sure your algorithm returns true or false properly, or celebrity or not. Okay.
I have one doubt here, Suresh. Now, as we constructed the graph before, let us
Yeah.
assume E doesn't know C. But
E doesn't know C.
yeah, E and C doesn't have any straight connections. But
Okay.
E to D and D to C. Does that mean E knows C? No, right?
Um. Yes and no, right? See, in a LinkedIn, see, I know you and you know your friend, but it doesn't mean that I know directly that guy, right? Let's say
Yeah, in that case, C is not a celebrity.
she is not a celebrity, exactly. So that's why it's a direct connection. It's not indirect connection. Of course, there is a connection. There is, yeah. You can navigate in a Facebook or LinkedIn. You can simply show you it's a one. It will show you order, right? First connection or third connection. Do you know that in a LinkedIn it will show you the number? This is
Mutual and LinkedIn will show the third connection first, second, and
exactly. Exactly. See that's it follows the same approach. So basically, it's a number of number of nodes between that. Is it third or is it fourth? So it will show that the number. Based on that, if we don't have E and C connected, but there is a connection with the middle one node, it will show you number two or something like that, second connected or something. Yeah, it will show you how many nodes between, or how many friends between those two nodes. Okay. Oh, LinkedIn is not opening for me, but anyway, so now you understood this, right? So let's go back to the problem. So here is the input. Did you understood input completely? Now C is celebrity, right? Look at the C is there. C is there in every adjacency list. 1, 2, 3, 4, and 5. And at the same time, C doesn't have any acquaintances. See, we did not add acquaintances for C, right? Now here is the find celebrity problem. So what are we doing is we are simply sending list of all the people. Celebrity, C celebrity, and I'm asking like try commenting the F above. If we are commenting this, you will see there is no celebrity. So here is the algorithm. So now, as I said, we can still use the list to iterate the people. We can still here you can hey you can stand everybody in a list. You can ask everybody. We have 6 nodes, right? 6 people. We will ask them to, they are in a list. They are already in a list has easy to navigate: 0, 1, 2, 3, 4, 5. So A, B, C, they are already in the list. Now you have 2 chairs. Now you need to take 2 people, right? You need to take 2 people. You can take A and you can take B, and now you will ask the question, do you know or no? Okay. Now what you do is, if you say yes, if you get yes, what you need to do is you need to eliminate this guy. And which guy you need to pick?
B.
No. Here you need to invite another people to sit in this seat, right?
Yeah.
See,
Okay. See,
there are two.
see, see.
Yeah,
So I'll
right?
pick
How
C.
do you know C? See, because it's already list of nodes. You are not eliminating. You are not moving A and B here. In order to pick C, you need to maintain some I or something. This I will tell you
Okay.
how many people you already took for the consideration. So now I pointed to number 2. Now you are asking, hey, please come the person to the dais who is at the location 2. You will ask, and you will announce in the mic saying, hey, the person who is sitting on the seat number 2, please come to the dais. Then C will come here, right? So now you need to have this third variable and you need to maintain this, right? So this is the way to do it. I think it's still possible just having a simple variable. It looks like it is possible, in my opinion. I'm just thinking loud. But the algorithm which I used I used a stack actually. So what I'm doing is I'm putting everybody in the stack. Okay, I will put something like this: E, let's say F here, E here, and D here, and C. Okay, and B, A. Okay, I will put everybody in the stack, and I will take these two people completely. Hey, remove completely. Don't reserve your seats or anything. Completely come to this dais. Okay. Now top of the stack is C, right? So I can simply say, hey, come top two people, top one guy, whoever is the top, come to the dais. I don't need to maintain in index. If I'm using a stack, right? I will simply saying, hey, come who is on the top of the stack. You got it?
Okay.
So just I think it's maybe it's additional. I'm not sure whether that's the right solution. It looks like I used the stack unnecessarily, but I may need to check again. According to your discussion, maybe by simply using a variable, this is easy to navigate. But in the solution which I wrote here, I used a stack. So here is the
Um,
algorithm.
because why I am saying because in my JavaScript, okay, yeah, in the program I have written graph, we'll keep track of each node in the graph. So the
Exactly.
adjacency list is a map, whereas
Yeah.
the nodes you add to the adjacency list, um, yeah, it is also a map. And we for BFS we use queue and a set, and
Yep.
as for DFS we use stack and a set. So that's
Stack.
how
Yeah.
it's programmed here. So it
Yeah.
is easy for me
But
to
here
track.
exactly. But here it's not DFS, it's not BFS. It's a different way of navigating. We will decide based on this question, yes or no. We don't
Okay.
blindly go to the connection of A to B, B to C, C to D, D to F. We don't do that, DFS. At the same time, we don't do the BFS as well. It's a different navigation,
Okay.
right? And it's not even navigation. We are keeping two variables, like the final solution here is P1 P2. We are, let's say, person 1, here is person 1 and person 2. There are two chairs, and this person 1 and person 2 are the chairs, are two temporary variables. We are maintaining two and asking everybody to sit in these two chairs, and finally at the end of the loop the stack becomes empty, and we will have two persons, P1 and P2. Now we need to decide who is the celebrity in these two people. That's what we
Okay.
do. Okay. So so what we do is, like, this is the way we implement it. So put all the elements in the stack. So for each, I'm putting every element in the stack. All the six people will be in the stack. Now, as I said before, I take two chairs or two variables, P1 and P2. And the peak, right? Peak will give you the top element. It won't
Yeah.
remove, but you can also simply say stack.pop. I popped it, and the P1 is the top element, and P2 is the next top element. So like A and B, if you think A and B. Now this is the for loop. Until the stack becomes empty, you do this. Until the stack becomes empty. So here is the algorithm. Here is the actual condition. So if P1 knows P2, if P1 knows P2, that means P1 knows P2 means P1 is not celebrity, right? Because P1 knows P2. So replace P1 with the next top element. It's exactly the taking the element from the list. See, right? You eliminated A here, and you took the C. You took the C from the list. Similarly, I am simply saying, hey, pop the element from the stack, and replace P1, because we know P1 already has an element which is not a celebrity. Okay. Else case, if it is else, that means P1 doesn't know P2, which implies that P2 is not celebrity, right? This is exactly the same condition I explained you in the first. So since P2 is not celebrity, you can happily replace P2. Got it?
Yes, Suresh.
So these are the exact two conditions I explained in the beginning. So if P1 knows P2, then P1 is not celebrity. If P1 doesn't know P2, P2 is not celebrity.
So it
So
is
based
like
on the
asking the minimum number of questions and deriving so many
yeah,
assumptions
we are
from the
asking only
question.
one question, right? We are asking only one question. So this is the minimum number. So we are not iterating through everybody. Let's say in the normal naive solution, you will take A and you will ask A, do you know A knows B, A knows C, A knows D. We'll take B, B knows C, B knows D, B knows A, B knows E. We are not doing n square solution. We are not asking the same question for every, and we are not taking one chair and asking this guy, hey, do you know rest of the people? We are not doing that. We are taking two chairs. We took two chairs instead of taking one chair. We took two chairs and we are asking those two people and decide who needs to eliminate. That is the minimum number of questions. It's not n square solution, right? Anyway, so you following, right? So
Yeah,
finally,
yeah.
and so at the end of this loop, finally we will have two chairs. P1 and P2 has two variables. So now we need to find celebrity. Here is the celebrity variable. If P1 knows P2, if P1 knows P2, finally there are two people, and P1 knows P2. That means P2 is celebrity because there is no other nodes. So if else, P2 knows P1. That means P1 is the guy who is known by everybody. So P1 is celebrity. But here, as I said before, this is not a final condition. Since we are not checking this, we are not checking the n square solution. We are not sure whether all the people knows P1 or not. Let's say P1 is celebrity, but we need to make sure everybody knows P1, not only just P2. Everybody need to know P1, right? Let's say in this situation P2 is celebrity. In this case, before we are mentioning, we are announcing P2 is celebrity, we need to make sure everybody knows P2. Okay, so that is what we make sure the person hold by celeb variable is a real celebrity. Since you are not doing n square comparisons, we are comparing only two variables at the end. We need to make sure the one who you are guessing a celebrity needs to be known by everybody. That is what we do here. This is a only one time thing. We already know, we already guessing this guy is a celebrity. That's why we are checking whether that guy is a real celebrity or not. So we are checking. This is a self thing. P not equal to celeb. Everybody, he knows himself, right? He knows himself. And then P, we are processing the list here. Every node P knows celeb. Or if not equal to, actually this is not equal to, if you find anybody who doesn't know celebrity, then no celebrity exists. Or if celebrity knows any of the people in the list, celebrity doesn't know P2. Here P1 knows P2, P2 doesn't know P1, but P2 doesn't know anybody also. That's something we are doing here. If celebrity knows any person in the list, then no celebrity exists in the party. Just we need to understand this condition very carefully. So finally, if you are able to finish this loop, if you are completely able to finish this loop without entering into this condition, that means a celebrity is the actual celebrity. This is a real celebrity that you found in this algorithm. Okay, this is complex, but
No,
very
no,
interesting.
no. This is interesting. This is
Very
good.
interesting, and but we have to be very complex. This is like very interesting. Yeah. So and finally, this is the function. This will tell you the celebrity or not. It will say celebrity exists or not. So you can try commenting this line, and you will see there is no celebrity. And if you uncomment this line, you will see the C celebrity. And here is another thing. Actually, I wrote another algorithm has connection. This is exactly like this. Do we have any connection from A to E? Like, it is not a direct connection. It is not a direct connection, but indirect connection, like LinkedIn connection. So A and E. Let's look at A and E into the graph. Is A and E connected? A and E.
No.
No. Let's look at
In
the
that graph, no.
other. Yeah, and A and F. Is A and F connected?
A and F, no.
A and
No,
F.
they are not.
No. There is a connection. There is a connection to A and F.
Okay. In which
A-
graph, Suresh? A
In
and
this graph, in the same graph.
A have no F in its adjacency.
It's not direct connection. It's not direct connection. The connect means like, do we have a path? Do we
Indirect
have a
connection,
path?
yeah. A to D and D to F, yeah, they have a path.
There is a path. So A to E, there is no connection. From A to E, there is no, because you can come to A to D, and from D you are stopped. You cannot navigate to E. So A to E, there is no connection, but A to F, it is there. This is like LinkedIn problem. Do you have LinkedIn or Facebook? Do you have a common friend, or do you have the connection? So it will automatically suggest, right? If you open the Facebook or if you open LinkedIn, this will tell you, hey, you may know this guy because of the connections. So that is the second algorithm, actually has connection. So I will give you two nodes in the same graph. Tell me whether you have the path or not. This is not like has connection means like it's not direct connection. It is a path. So find if we can reach P1 to P2 by using P1's acquaintances graph. That is what it is. Basically, you will start with P1 and find and see whether you can reach P2 using the acquaintances of the P1. Acquaintances means the friends of P1 by using all the friends of. So I will tell you two people in the LinkedIn, Suresh and Karanya. And we will see whether you will loop through the friends of Suresh and friends of those friends, friends of those friends, friends of those friends. Finally, if you're able to reach P2, then you will say, hey, it will return the true.
Okay.
This is nothing. This is just a DFS. This is just DFS or BFS. You can use any algorithm. This is already we discussed about this.
Yes.
We completely discussed. The only thing is we are instead of adjacency list, we are saying, hey, give all the acquaintances. Only the method name. This is the only line which will change. We already discussed about this in the previous algorithm. In the last week we discussed like node dot get adjacencies list or get children. But here we are asking, hey, give me all the acquaintances. So we will put it in a stack, and we are running in a stack, and this is exactly a simple DFS that will tell you. But we are here we are checking for every time if you are popping out of the stack. Is it the node you want to reach? Is this the person you want your? If you are searching for this person, hey, we found it, simply return true. But if you are at end of the stack, if you processed all the acquaintances and you did not find it, then you simply return false. This is just a DFS, nothing else. So these are the two algorithms. I will give you the link, and please take your time and understand. And it will be definitely very helpful, very, very interesting problem. Okay.
Okay.
Yeah, cool. Then. So here it will show you that there is you see the third. This is like third connection for me. There will be middle person is here, right? This is saying third place, right?
Okay.
So this is what the connections, number of connections between different. Yep. Cool. And it's almost like 10 o'clock, and I hope you liked it. Let me know if you have any questions. I think we lost Arvind there. Probably he will join, and we'll share the recording. I will share the algorithm as well. Okay.
Okay, Suresh. Yeah, thank you.
Next week either
nice
we can
session.
review.
Thank you.
No problem. Yeah. So next week we can review these algorithms. If you have any questions, or I can I can also do some mock interview if you want. Anything is fine. Tell me what you want me to do next week.
Okay,
Okay.
sure.
Awesome.
Yeah.
Awesome. Then yeah, have a nice week, and
Have
that's
a
it
nice
for today.
week too, Suresh.
Yeah.
When are you coming to India?